Alright, this is Mr. Gillum, and today we're going to start measuring angles and arcs and learning about the lengths of arcs. And so some of the stuff we already know is that the degrees in a circle add up to 360. And you've learned that in your previous classes. And it might not have made sense because it doesn't look like there is any angles on a circle. But the angles that they're talking about are the central angles. So from here all the way around to there again is 360 degrees. So, for example, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 would equal 360 degrees because there's a total of 360 degrees all the way around. Okay, so that's what I want you to know. You probably knew that already. So if I asked you to find the value of x, and I know that the sum of these three angles equals 360, you could probably do that pretty easily. You would say that I have 130 degrees, plus I have another 90 degrees for the right angle, plus I have this unknown length, x. I know it has to equal 360 degrees. So if I want to find the missing angle measure, I could solve this equation. And with that, I know that x would equal 140 degrees. Okay, so hopefully just a little bit of review there. We're going to throw a little algebra in there with our geometry today. Solve the missing angle. Now, this is what is probably new information, and it has to do with arcs. Okay, an arc is a portion of a circle divided by two endpoints, and the endpoints are actually on the circle. So the arc PR would be from here to here, or from here to here. Each of these is an arc. Okay, and there's a red arc on your diagram here, and in your paper it'd be black and white, but there's an arc from P to R or P to R, depending on which way you look at it. Okay, and the central angle is the one that separates the circle into the two arcs. So this angle separates the circle into two arcs. Okay, the endpoints of the angle make the two arcs. If it's a minor arc, the degrees are less than 180. All right. If it's a major arc, obviously, the degrees are more than 180. So I have the same central angle on both diagrams here. As you can see, it's the same diagram. The minor arc between A and B would be the short distance, less than 180, and the major arc would be the long distance, around. Okay? So each angle makes a minor and a major arc unless it's a semicircle. It's exactly halfway in between. And the arc lengths are exactly the same, and it's a perfect diameter across if we're talking about a semicircle. All right, so hopefully all this stuff makes pretty good sense. It's going to be easy to remember because minor means less, and we're talking about less than 180, and major means more than 180. In this instance, it says that GJ is the diameter of circle K. Identify each arc as a major arc, minor arc, or semicircle, then find its measure. Okay, I can do that. The measure of arc GH. So looks like this guy right here. I should make a side note. Arc GH is referring to a minor arc unless otherwise specified. Okay, if it's just two letters, it's referring to the minor part of it. If I wanted, so it's referring to GH right here. If it were referring to the major part, it would say arc GLH or GJH. It would add another letter in there to indicate that you're going the major arc distance instead of the minor arc distance. So if you only see two letters, it's referring to always the minor arc distance. So in this case, arc GH is 122 degrees. Okay, it is a minor arc. All right, let's use a different color for the next one. It says measure of arc GLH. So now, as you can see, it's talking about the major arc here, all the way around. So we're going to say it's a major arc. And its measure would be whatever's left from the 122. So it's all this portion, not including the 122. So we have 360 degrees total minus the 122 that we don't want, leaves us with 238 degrees. Okay, and then finally we have arc GLJ. So in this case, from here, halfway around exactly, we call this a semicircle. It's exactly halfway around because it lands on a diameter. And I know that in a semicircle, there's exactly 180 degrees. It's half of a circle. All right, so there's just an application of the vocabulary terms as well as how to figure out which angle is which, how much it is. Congruent circles are important as well, and you'll know that the circles are congruent if they have exactly the same radius on both of them, or in this case, if they have two minor arcs that are congruent, if and only if their central angles are congruent. So if angle 1 and angle 2 are congruent, and they're not necessarily vertical in this case, then I know that if the angles are congruent, it's taking the same percent of the total degrees from this circle. So if these are the same, then this arc for FG and this arc for JH are also congruent. Okay? It works backwards and forwards. So if angle 1 and angle 2 are equal, then their arc lengths are equal. If the arc lengths are equal, then the angles are equal. So if we know FG and JH are congruent distances, then we know that angle 1 must equal angle 2, or be congruent to angle 2. If I knew that angle 1 was congruent to angle 2, then I would know that these arc lengths are congruent. Okay, so it kind of goes both ways. Now I'm looking at the circle graph here, and I'm going to kind of try to answer the questions about this. It's a little trickier. Actually, just one second here. So what I'm doing now is I'm not finding the actual number of females participating. I just want to find the measure of the angle of the central angle of this pie graph here. So what I mean by that is this. If I'm looking for the measure of CD, and because there's only 2 letters, I know it's indicating that I just want to find this length right here, this arc length. But I know that this blue triangle takes up 18% of the entire circle. That means that this guy right here, this arc measure, is 18% of 360 degrees. All right, if the central angle is 18%, the arc length is 18% of the total. So what I'm going to do is I'm going to take my 360 degrees and I'm going to find 18% of that. That will represent the measure of the arc length. So when I change percent into a decimal, I'm going to multiply it by 0.18, move the decimal place twice, and calculate. $64.8. All right, 64.8 degrees will be the measure of arc CD. The measure of arc BC, let's do a different color. As you can see, the arcs, or sorry, I should say the central angles will be exactly the same because they're both 18% of the total circle. So instead of doing the same work again, this is just kind of reestablishing that the arc length of BC would also be 64.8 degrees because of what we just talked about here. If these are the same, then these are the same. All right, so that's just kind of a reiteration of that information. If I were trying to find soccer, I would do 14% to find the arc length, 14% of 360. If I was trying to find basketball, I'd do 20% of the 360. Okay, it's representative of a total of 360 degrees. Adjacent arcs are almost exactly like adjacent angles. Okay, the central angles will be adjacent. The arcs will be adjacent as well, meaning right next to each other. Okay, so as you can see, these angles here we know are adjacent. That means their arc lengths are also going to be adjacent. They're going to be right up next to each other, exactly like that. So when it refers to adjacent arcs, it means they're touching each other. The one point they have in common would be the edge point right there. All right, adjacent. So I know I'm moving through these a little quicker, but a lot of these vocab terms make sense in their own right for a circle because we've used them in angles before. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. That was really confusing, but what it means is this. If I have an arc formed here and an arc formed here, then the sum of the central angles is also the sum of the measure of the arc lengths. Okay, so the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the two arcs. So I could add this guy plus this guy. So I could say the measure of arc xy plus the measure of arc yz equals the measure of arc xyz or zyx. Those are, again, you can mix those variables up if you want, those letters up, and it's okay. If we said that would be the same as measure of zyx. Okay. So that's just what it's saying. It's just like the segment addition postulate. So one segment plus the next is the total thing. Okay, so it should all be pretty familiar. Just find each measure in circle F. So let's try to find some arc lengths. AED is represented by this arc right to here, and it looks to me like I have a central angle of 63 degrees and 90 degrees. So simply to find measure of arc AED, I would take 63 plus 90, 153 degrees. The measure of arc ADB would be all the way even farther than that even. Okay, so let's see here. How would we find, I'm going to erase this and kind of make sure everybody sees which one I'm talking about here. How could I find from A to B? What I notice about BE is that it's a diameter, or in that case, making the arc length from B to E a semicircle, or 180 degrees. So from here to here, I know that's 180 degrees. I also have this last portion here from A to E represented by 63 degrees. So I'm going to take 180 plus 63 to equal 243 degrees for my arc length. All right. So here we go. Arc length is, like we were saying, a percent of the circumference. Okay, it's a percent of the total. So when we start actually putting numbers with our radius, this is what we're going to do. Okay, we know the arc length is equal to the percent out of 360. So we're talking about, like, if this was 30 degrees, it'd be 30 of the 360. If it was 90 degrees, it'd be 90 out of the 360 times the circumference. In this case, we're going to leave it in terms of pi and radii, 2 pi r. Okay, so this is the formula to find arc length. All right, you need to have the central angle represented by x and that much of the 360 multiplied by the circumference. Okay, so we're finding a partial part of the entire circumference is basically what we're doing. So on the first one here, it says find the arc length of zy, round to the nearest hundredth. So I'm going to get my calculator ready here and let's figure this out. I see that zy has a central angle of 75 degrees. That's 75 out of the total of 360 degrees. Okay, so we don't want the whole circumference. We want 75 360ths of the circumference. Now the circumference is 2 times pi times r. In this case, r is 4. So now it's just a matter of typing it in your calculator. It does say round to the nearest hundredth, so what I'm going to say is that our arc length is 5.23. And it looks to me like in my calculator it's repeating, but it does say round to the nearest hundredth, so I'm going to leave it at that. Okay, again, this is the percent of the total circle that I want, or the percent of the total circumference that I want, and the total circumference is represented by 2 pi r. All right, let's set up the next one here. Looks like when we're trying to find the arc length of zy. So I have 130 degrees out of the total 360 degrees, meaning I want 130 360ths of the total circumference. So I'm going to multiply that by 2 pi r. In this case, they don't give me the radius, they give me the diameter, but I know that a radius would be half the diameter, so the radius would be 5 centimeters. Multiply it by 5. Now it's just a matter of typing it in your calculator. Remember, if it bothers you having a fraction times a whole number, you can just put it over 1. You multiply straight across the top, straight across the bottom. In this case, we're going to divide it out to find the decimal, and I'm going to go ahead and do that right now. So if you're following along at home, what I did is I took 130 times 2 times pi times 5, enter in my calculator, then I divided it all by 360, and I got 11.34 to the nearest hundredth. It was like 338888888, but it does say it's round to the nearest hundredth, so that's what I'm going to do. I should always label my answers as well. These are distances, so we're going to just label them in inches and centimeters. Let's set up the last one here quickly. Again, I have a 75-degree angle, and I'm trying to find zy. So I have 75 of the 360 degrees times the circumference of the whole circle, times 2 times pi times 6. For my calculation, what I get is 7.85 inches. All right.